Welcome to the third Railway Talk. We're very happy to be here today and have so many guests from all over Europe and even outside Europe. Thank you for joining us. This is the third edition of the Railway Talks that we have initiated this year. And my name is Charlotte Gebhart. I'm from the Union of the European Railway Engineer Associations. And I would like to just briefly introduce you to what the union does. Some of you might know and some might not. So please, could I have the next slide?
Sure.
Thank you. So the union is an umbrella organization of European Railway Engineering Associations and a platform for knowledge exchange and transfer to railway engineers. Basically, what we do is networking, and you see here all our members with their logos. On the next slide, you will see all the locations where we are. In Europe, if your country is not on the map yet, please feel free to contact us. We're very interested in widening our network and getting new members from countries that are not included yet. Please, the next slide. So what we do is we connect, share, and certify. This is our mission. So we create networking opportunities, like, for example, this one, or we take part in trade shows, different events. We share our knowledge, and we certify railway engineers, which is very important. Some of you that are present might already be EuroINGs. If you don't know anything about it and you would like to learn about this certification, feel free to visit our website. We have a certification that is European-wide recognized, and you will find all the requirements on the website. And if you have any questions, feel free to write us about it. On the next page, you will see this is a certificate when you get it. And that is all from me. And I would like to introduce you to Wawrzyniec, who is our moderator today, our presenter. He will also lead the discussion. He will introduce briefly the Polish member association that is called SITK. And then also we thank him very much for supporting this Railway Talk with his company, Metroprojekt. They will have the second presentation, and the first presentation is from TrackTec, from the colleagues that you see online here. And I hand over to you, Wawrzyniec.
Thanks a lot, Charlotte. So first of all, I would like to say thank you to President Olaf for having us here, because we are happy to present, let's say, the Polish knowledge, the Polish technology, and we are happy to be here with you. So, of course, SITK is the member of your organization. Same story is related to TrackTec. So we are together supporting the union. And the first presentation is just to present to all of the audience the high-speed railway program, which is currently ongoing in Poland. Okay, it's just to let you know that here in the middle of Europe, we are starting the big scale infrastructure program, which is related to the high-speed railway. These slides you already seen, and very quickly about our organization, because the Polish Association of the Transport Engineers and Technicals is the biggest organization in Poland. There is 5,000 members behind this logo. Okay, we represent a few branches. Of course, the most important one is the railway, but there is highways, there is road engineering, of course, there is civil engineering, there is avionics and other means of transport. So all of these things you can find behind this logo. So we are representing the transport engineers across Poland. Okay, coming back to the high-speed rail program. So this is something new here in Poland. Okay, so as you can see, there is a huge plan which consists of almost 2,000 kilometers of new high-speed railway lines across all of the country. So the network is centralized because in the middle you can see the hub. Let's call it like the transportation hub because it collects all of the means of the transport. So again, the roads, again, the avionics, the airport, the huge airport hub, and of course, the railway. By color red, you can see the lines which are currently under the design process, okay? So it is expected to finalize it till 2034. In Poland, we are still thinking about the core of this network, and this core of this network is called the letter Y because of the shape of this network, okay? So it is the railway line which connects the major cities, which is the Łódź, Warsaw, which is the capital, Poznań, and Wrocław. And what is important here, we are talking since years about this program, okay? It's 15 years or more. But today we start a real process of design, okay? And you will see in the next slides that this program is currently ongoing, that we are at, and you will realize that we are on the design phase, but we are very close to the execution works. Here you can find some dates. Let's call it like this. It's the typical approach, right? So there is a pre-designed documentation for these sections. There is, of course, a project documentation. Of course, the contract engineer certification works to prepare the construction works and the construction works at the end. Of course, you cannot see here all of the topics related to this moment, okay? So the test and commissioning programs and so on. But here is just to present you that at the end of 2023, most of these lines will be at this level, construction works. When we are thinking about the high speed in Poland, we have to see that this is very optimistic program, okay? So design speed is up to 350. Same story like in Italy. Operational speed is 250. Of course, when we are thinking about the new network, we have to consider the new type of the power supply, which is the double 25 kV alternating current. This is a, let's say, typical solution. So full connectivity with the existing railway system. This is something unique because in many countries, the high-speed network is totally separated. In Poland, we would like to be connected to the existing, let's say, traditional railway. This program is divided into the phases, okay? So there is a study phase, there is a design phase, and the others, okay? So what is important here? The new approach at the Polish market, which is the framework, okay? We would like to define the short list of companies responsible for the specific phases of this program. Here you can see some kind of summary for the study phase. So let's say there is 13 companies, okay? This is the amount of money behind this program. So it's 1.2 billion zlotys. At the end of this presentation, I will try to do short converse between the zlotys and euros, okay? But I think that when you divide it by 5, you can see the scale of the program, okay? Next phase is the design phase, and this is something that we are already in. Again, there is another 11 companies from the countries like Poland, of course, Spain, France, Germany, and Korea. So there is a lot of entities with the huge experience in high-speed railway across the Europe and outside the Europe. The budget behind this program is 7 billion zlotys. Again, divide by 5, you can see the amount in euros, okay? Traction power supply, something new here again. So we have double 25 kV. This is similar story like in Italy. So existing system at the conventional lines is 3 kV DC, okay? And within this project, we have to design 13 of new TPS, let's say traction power substations, okay? These substations will be ready to supply the high-speed trains traveling across this new network in Poland. So if you are thinking about the high-speed railway, you have to define the input. Okay, you have to define the standards. So together with Institute Kolejnictwa, sorry, not together. Institute Kolejnictwa developed these standards. Okay, there is a version 2.0 in force. You can find a lot of details, technical details behind, which describes our approach to the high-speed railway in Poland. Okay, of course, these standards are still under the revision, and they are discussed with the French entities, the Spanish entities, so let's call it like this, with the companies or entities with the experience in high-speed railway. In Poland, we do not have the rolling stock ready to be used at the high-speed railway. That's why, again, the shortlist for 10 companies like Alstom, like Hitachi, like the biggest ones, okay, with the minor representation of the local Polish companies, to be ready and to be prepared for the moment when the network will be ready to be put it into the operation. Then we will have, let's say, the new type of trains ready to be operated at the speed of 250 and even above. Okay. This program in Poland is connected to the Europe, let's say. We have to consider that we are in the somehow in the middle, let's call it like this, and we have to be connected. There is a project of the Baltic states, which is Rail Baltica. Probably most of you heard about this project because it's a little bit more advanced than the things that we are doing in Poland. And we are connected. We are connected to Rail Baltica. We are considering the connection to the Ukraine because of the strategic things. And of course, we would like to be connected to the rest of the Europe. And this is one of the things. Here you can see the Rail Baltica in Poland. Okay, so this is just the part of Rail Baltica which is already placed in Poland. Okay, and the 3Cs initiative. This is something probably new for most of you, but here we are trying to be connected to the, let's say, neighbor countries like Czech Republic, like Slovakia, like the Baltic states, and Ukraine, of course. So program which is ongoing in Poland is somehow connected to all of the neighbors. Of course, we would like to have the straight connection to Berlin. We would like to travel fast to Vienna. Of course, it is considered to put the regular track to Lviv and further to Kiev and so on and so on. So all of these stories are connected and they are in line somehow with the program that we are already facing in Poland. And this is all for this first presentation, and I'm waiting for your questions. There is two ways of asking the questions. Okay, you can just drop it at the chat. Then at the end of the presentation, we will come back to them. And you can raise your hand at the end of every presentation just to drop it on the table. Okay, and we are ready with our colleagues from TrackTec and with our colleagues from Metroprojekt to answer the questions. So now let me introduce Piotr and Przemek, who represents TrackTec. And guys, the floor is yours, and please share your presentation, okay?
Okay, hello. I hope that you can hear us properly.
It's okay.
Okay, I'm gonna share the screen right now. Okay, so I hope that you can see the presentation. Okay, so good day. I'm Przemyslaw and Stanislawski. I'm here with my colleague Piotr Piech.
Hi.
We are both representing the TrackTec group. What can I say? We are both engineers. We are working in the research and development department in Katowice. And we would love to share with you our presentation with such a long topic, which is detecting anomalies in railway infrastructure with advanced data analysis techniques. And I know it sounds pretty complex, but I hope that afterwards you will be able to say that it became a bit clearer. And anyway, we would love to share with you the results of the work which we have done in research and development of this topic. Okay, so the first question is, we have to ask a question. Why? Why do we even bother? Why do we even bother with investigating the anomalies in the railways? And this question can be crucial. And there can be numerous reasons why we should focus on detecting anomalies. But above all of them, nothing is more crucial than safety. And it should be a top priority for everyone involved, whether as a company, a passenger, a member of the public, and ensuring safety is of utmost importance in the railway industry. When it comes to anomalies, what this term actually encompasses? Let's name 3 groups of railway infrastructure elements that are susceptible to anomalies, such as rails, ballast, fasteners. If we will focus, for example, on just rails, we can differentiate at least 4 types of anomalies, such as fracture, cracks, bend, and head checks. In some cases, a part of fastening can be missing, just like here. Yeah, the part of a clip is missing. Or in this case, for example, we can witness a bolt hole cracking, situation which also frequently happens. And there are already many anomaly detection methods, starting from visual inspection, ultrasonic testing, acoustic monitoring, infrared thermography, track geometry measurement, and ground penetrating radar. And we focused on developing solutions based on vibration-based methods. And here is a little sneak peek. How does it look? Here it is assembled. Here it is disassembled. When it comes to how it is made, it consists of electrical insulator, accelerometer, polymer housing. And when it comes to accelerometer, which we are using in our solution, we are using a special triaxial one. It is a piezoelectric accelerometer. It has got a military-grade durable housing. But to be able to quickly, rapidly analyze millions of samples which we're going to receive, we're using a specialized DSP processor, which stands for Digital Signal Processor. It help us with noise filtering and provide efficient calculations with high-speed processing. But to tell you more about how this works, here is Piotr.
In macro scale, the system consists of 2 accelerometers attached to the bottom of the rail. When the train is coming, both of the sensors feel the vibrations and it generates the voltage signal by the piezoelectric effect. Thanks to that, we know the distance between 2 sensors. We can estimate the position of the propagation starts. But how we know which signal is causal and which one comes from anomalies? At first, we have to filter data. In our case, the best filter family was the recursive filters, like, for example, Kalman filter. Next, we have to perform Fourier analysis to get the frequencies, the dominant frequencies. The Fourier transform have such nice advantage that it's not sensitive to some random noises. However, the frequency may change in time, so we have to make also spectrograms. As you can see, even now, without anomalies, the signals differ from each other. But how we can find the anomalies by human eye? We can find some different frequencies, some peaks, something is changed. But if we have millions or even billions of samples, the human is not able to analyze that. Moreover, if you have some pattern of signal that represents some physical phenomena, we are not really sure if if this is what we think, we have to do a lot of measurements and it take a lot of times. But we hope that we found some solution. To know more about that, let's back to Przemek.
Thank you, Piotr. Because of those issues that Piotr was just discussing, we have to rely on advanced data analysis methods, such as neural network. And neural network are very complex structures. They consist of input layers, hidden layers, output layers. Those circles here, they're called neurons, and they're linked and tangled to each other. If we have to summarize somehow, how does it work? We can just use those 4 words, such as data, learning, computation, and prediction. Okay, so anyway, how we can use them? Let's compare 2 setups. At the top, we have a regular, undamaged setup, and at the bottom, there is a setup with easy-to-spot rail crack. Signals collected by accelerometers are complex and uncomparable by human eye. And this is the place where the neural network comes. We are using a very specific data points on each of those graphs. And we are using them as an input to our neural network. We are just feeding our neural network with it. So those points become our first layer of the neural network. And thanks to that, and thanks to a lot of calculations in hidden layers, we were receiving informations. It is possible to receive information about position of anomalies in the rail. Last year, we were able to show the live demo of the system during Berlin InnoTrans Fair. During the last few years, we were able to install electrical sensors on hydraulic drives on one of our high-speed turnouts. This one is in Psarski. Together with live weather informations, we are analyzing voltages and currents of hydraulic drives and totally remotely spot warring behavior of it. And that's all what we've prepared today for you. Thank you so much for your time. I hope that you liked it. And as I said at the beginning, it became a little more clear for you. Thank you.
Thank you.
Piotr and Przemek is not so easy. Now the questions, because we checked the chat. There is no questions to you at this moment, but sorry, I have a few. Okay, and I would like to share with all of our audience with my screen, and probably you can see it right now. So there is just 3 questions from my side, okay? I don't know if you can see the questions right now, but
okay.
Okay, so the first one, Przemku, can you just read it and try to answer, okay?
Okay, so the first question is, what was the longest distance between accelerometers that you tested? We tested that setup with accelerometers within the distance of 50 meters, and I'm going to say only 50 meters because right now we are a company that produces sleepers and bearers, but also regular turnouts and tram turnouts. And the idea is right now to use that kind of analytic solutions such as, for example, turnout. So we were able to install it on a turnout, but on a private tracks, and that's why the distance right now, which we're talking about, is 50 meters. It is possible to set it further ahead, but right now we are not. We haven't done any tested except that on a turnout. And the second question is, can your system be used to create an axle counter? Short question is yes, it is possible, because the regular axle counter just counter the amount of axles that of the train that's passing by, and it is possible because we can spot on the graph using also neural networks, for example, that the peaks of the each axles, and we can just analyze them, calculate them, and yeah, so yeah, it is possible to use them as an axle counter. And the last question, which is here, says, do you plan to commercialize your solution? Right now, we are showing, that was the little sneak peek of what we are doing in the research and development department, what we're working on. We're not bragging. We just wanted to share with all of you our knowledge, our skills, and maybe other company is going to work on that. And right now we are not commercializing the solution. I'm pretty sure that we will show that also on the next fairs. And then the next one, the next big fairs in Europe is going to be in Gdańsk, if I could remember. So probably there is going to be once again a small demo, a live demo, and people can see how it works. But right now we are not planning to commercialize our solution.
Okay, thank you. And of course, the question is, are you preparing as a TrackTec to the high-speed railway program in Poland? And of course, I know the answer, but I would like you to answer to all of the audience that you are working on this program for sure.
Yep. We are focusing also on a high-speed turnouts in producing them. The one of the slides on our presentation been showing a turnout that exists. That's our turnout with Alstom hydraulic drives. There are 2 of them installed on that spot. Yeah, so we are focusing on a high speed pretty much because how the railway should grow. That's the way how the of the whole the company that should go into like the fast high speed railway and yeah. So we are eager to work on the high speed project in the future. Yeah.
Super. So we've got some questions at the chat. You can see it. Okay. So maybe the questions to the first presentation, we will, let's say, come back to this at the end, but let's focus on the questions that are directly related to your presentation. Okay. So let's start from this one, from Olaf. Okay. Can you see it? Are the solutions from TrackTec? Can you see it, or you want me to paste it? Okay, give me a second. Give me a second. Okay?
Or because it's going to be easier.
Of course, John. So here you've got the question. Okay, number 4. Okay.
Hold on, I cannot see anything. Oh, here. I'm sorry. Yeah.
Okay. No worries.
Are the solutions from TrackTec, which they have installed in hydraulic, foreseen in the new HSR line? I don't know. Will they be in the new HSR line? I hope that they will. I cannot answer for a whole company. We're working on our R&D, so I hope that there will. But I know about that, so I cannot answer specifically, to be honest.
Okay, but there is new one. You have the 5th one. Sorry, okay. A lot of questions.
Yeah, sure. Yeah, an accelerometer. My understanding is filling up with rail every X meters. What is the number of sensors that can be grabbed by such a collector? I guess you will have something like different level of lease nodes. Yeah. So what for turnout?
And this question, just to let you know, is from Giuseppe. Okay. So the 5th one.
Okay. Hold on. Let me read it once again. What is an X number of sensors that?
Charlotte, I'm sorry, Przemku. Charlotte, maybe we can, let's say, let Giuseppe define the question in details, okay? Just to, if you can find him. Okay.
Let me just
Giuseppe,
see,
could you please raise a hand? Then it will be easier to find you in the list of almost 100 participants, okay? Oh, we have you.
Okay.
The title is The Railway Talks. We have to talk.
Yes,
okay?
You can enable your
Giuseppe, is it possible
your microphone now?
To enable your microphone right now? Or
here we go. You hear me?
Super.
Okay, very well. Yes, just it was a matter of understanding the network for managing so many sensors. I guess if you have a sensor every 10 meters, I imagine that you have like a data collector every, I don't know, 100 sensor or something like that. And then you have a higher level even that takes the data from the first level of data collector, like a pyramid of sensor, I guess. But it was just my guessing. That is the question.
Okay, if I could understand, I can. The idea is to install, because on the presentation we showed that there are just two devices, like two accelerometers, distance, for example, like 50 meters or 100 meters, etc. As I've tried to answer before, we haven't tested that on the higher distances, but it is technically possible because we have achieved a positive, let me say, response from the accelerometers during our tests. So technically we are planning to, because this is the question, if you're asking how many of the accelerometers which we have to use on a regular track, for example, we are not still managing that problem because we are still, let me say, in the phase of defining the product and defining also the use for it. Right now we're using that only in R&D. It's not released yet. We're planning to use that kind of solutions on our products, only for our internal use, for our products and turnouts, for example. So right now we're planning to install 4 of them on turnouts and wrap and close data as much data as possible. Of course, we're using, I haven't showed you that because I cannot show everything, sadly, because my boss would be bad, but we are also, we have to do analog to digital conversion in the background. As I've tried to show you on a presentation, we've been doing, we are using a DSP with over a megahertz frequencies. And yeah, I hope that I answered your question. I'm sorry if I didn't understand it properly.
I was, now I get it. You are filling up the data set. Let me say like that, in order to understand what happened, what signal means what. This is the develop phase you are doing right now. Okay, get it. Yep. Thanks a lot.
Thank you.
Thanks a lot, Giuseppe. So guys, next question number 7 and 8, and after that we have to switch into the next presentation. Okay.
Okay. So question extremely quickly. On a high-level view, is a function of your analysis network cross-correlation analysis. We're using cross-correlation analysis in our new network. Yes, that's true. This goes to the TrackTec team. Do you plan to extend this study to railway track with the steel sleepers? Right now, we've been testing our system only on the concrete sleepers, but if we will, let me say, if we're gonna, because right now we are collecting data as much as possible to use it to learn our neural network how to differentiate its type or each type of anomaly. So maybe in the future, yeah, that is an idea to use it on steel sleepers. And the question number 8. What was the expertise of close investigation of problematic stretches? Is there any pattern of degradations of grade formation rail passing subtype rails? Closer investigation of problematic stretches. I know if I could understand, but is there any pattern of degradation? Yeah, we are trying to look for the patterns. For example, if there is an uneven ballast layer, or if there is a crack in the rail. This is, as the Peter to tell that it's extremely hard to differentiate for human eye. Yeah, so it's even with regular filters. Yeah, even with some kind of mathematical methodology, it is very hard to differentiate. For example, if there's an uneven layer ballast, or if the bolt is cracking, if the bolt hole is cracking. Yeah, but right now we figure out few patterns thanks to neural network. We have got over 93 or 4% of positive positive response from our new network. And we are still, let me say, rebuilding it. We are still collecting data. That's the phase that.
Yes, but if you are not going to use neural networks, of course, you can use, for example, Excel, take the data and look for the patterns. For example, if we have crack on the rail, we can find some extra frequency. What you have for fastening system. If fastening system is broken, the stiffness of the system loss. When system of stiffness loss and connection between rail and sleeper is not so strong as the beginning, the energy of dissipation of the vibration is different. So you can find some patterns, but it's not easy to do on your own.
With that neural network. Okay, yeah, I hope that we've answered all the questions then.
Thanks a lot, Piotr and Przemek. And at the end, I would like to ask you, because it's not related directly to your, let's say, technical knowledge, but this year there is a TRACO in Gdańsk, right? And for sure, TrackTec will be there because it's the biggest event here in Poland. So I would like you to invite all of the audience, because Union and this Railway Talks is the platform to discuss, okay? But if you want to meet these experts in person, I'm talking about Piotr and Przemek, just arrive to Gdańsk and find the TrackTec booth. And you will be there, right? For sure.
Yeah, we're going to be there. We want to invite all of the guests here. All of you are welcome. It's going to take it's going to be for 3 or 4 days, the TRACO. So there's going to be time to meet and greet, to talk about, I know, diagnostics, accelerometers, neural networks, whatever you want. We love to see you there.
Thanks a lot, guys. So now, now it's the time for the next presentation, which is related as well to the high-speed railway, but now we will talk about the design process, okay? And we would like to show to all of you how we are trying to solve the issues related to the design phase of the high-speed railway program with the use of the BIM technology, okay? So guys, I do not know who will start, but please share your screen and present the Metro project and the way that we are using BIM in our design phase. Okay, thank you.
Okay, thank you, Wawrzyniec. My name is Jakub Psarski and I'm railway engineer. And together with my colleagues Jakub Schulz, who's a construction engineer, and Patryk Bartuzi, who is CCS engineer, we'll show you how BIM technology is used in railway infrastructure related projects in Poland. For the beginning, every design process in railway infrastructure starts, of course, with railway model. So how it looks using BIM technology and BIM tools gives opportunity to make model more and more saturated with data. Railway model consists of components such as clearance, which will be shown in later slides, which is in compliance with standards, of course. It may include things such as allowances for enlargements in tunnels, changes in pantograph clearance height. The model consists also track axes, which are made in form of 3D solids to be easier to use by other designers. We can, as you see in the slide, we can have 3D models of rails with, I would say, precise representation of cross sections of various profiles. Rail supports, of course, may be made in different form. For example, as here shown, block supports, but also we can make sleepers in the way of any way we like. Any type of sleeper, from wooden sleepers to concrete sleepers of different sizes. Of course, supports are positioned along the track according to specified spacing. We can create model of different track types. Here you can see ballastless track, but of course there is possibility to make standard ballast track. All the models or the types of tracks can have various heights of layers. For example, in ballast track, we can have layers such as ballast, sub-ballast, frost protective layer, subgrade, and even vibration isolation elements such as under ballast mats. Of course, every layer and element can be adapted by the designer to the expected width, thickness, or slope. Ballastless track includes track slabs and different form of vibration isolation, for example, under slab mats, side mats. Additionally, we can include in our model drainage system. It can be in form of ditches, in form of drainage channels, and this gives us many opportunities, and we can make model from almost every inch of the track. Most important in 3D BIM models is data. It's important that every part of the model can be saturated with parameters which can describe many different properties. It can start with properties such as track number, line number, even unique class identification, and in parameters such as width, thickness, or a material which from is made the layer.
Kuba, I just
Yes.
would like to ask you, take the microphone a little bit higher, okay? Because of the quality
Okay.
of the voice. Oh, now it's super. Thank you.
Okay. All 2D documentation is made from 3D models. This keeps the documentation consistent and eliminates the risk of differences between all the documents. You can see on the slide 3D model of slab track, and from the model we can make 2D documentation of different types. For example, we can make the plane which includes slabs, and we can make a different 2D drawing with track axis, with turnouts, and the documentation is consistent, which is the most important in situations like changes in the project, changes in the design. You don't have to change every drawing one by one. If you make the change in 3D model, the changes are automatically transformed into 2D drawings. Of course, there are another types of 2D drawings, like in this slide, cross sections. Cross sections can be made in almost every kilometer using different styles as shown in this example, and dimensions, which you can see in lower part of the graphic, are generated automatically, which allows us designers to check if there are no mistakes. Another very important thing in using BIM methodology and BIM models in design are calculations. The most important calculations in railway branch are airfork balance. As many of you probably know, the airfork balance may generate many millions or even billions of dollars or euros of cost in building process. So it is very important to make airfork balance as precise as possible. Manually, there is possibility to calculate this balance using cross-section method, which is based on approximations which may generate inaccuracies or even mistakes. We can use 3D models to generate airfork balance directly from model based on difference between surfaces generated from the existing terrain and from the lower surfaces of various layers, including the lower layers of railway track and drainage. After calculating the balance, there is possibility to show results in different ways. As you can see in this example, you can even turn the calculations into 2D model with colors that symbolize, for example, cuttings or fill areas. Now I will pass the voice to my colleagues and they will show more from their branches.
Okay, guys, very important thing to keep the microphone close to your face, okay?
Okay. Hello, I'm Jakub Schulz, and like my friend said earlier, I'll cover part about construction. We're sorry about this inconvenience with our microphone, but our main device appeared to not work before the start. But as part of our work, we're engineers, so we had to find a solution. So to begin with, building information modeling, BIM, is well known in architecture and structural design. But when we talk about railway, construction in railway, it's still kind of innovation in Poland. But implementing BIM technology makes our job easier, especially when we talk about coordination between all branches. Work done in a railway model by my colleagues is starting point for me. But we can work in many different ways. Modeling can be done manually, and even then using 3D models from all branches is really time saving. But parameterization is the thing that optimizes the task on an unimaginable level. Track axes in form of 3D polylines are path which we encapsulate with construction. So like with use of Dynamo scripts, it allows us to automatize repeatable tasks. Dimensions of elements and their distance to axis is parameterized, and modeling can be done almost automatically. Any drastic change in project doesn't mean time-consuming remodeling anymore. Like I said before, coordination is way easier. I can identify any collisions in just a moment, and any interference, and just eliminate in real time. It is very important too that Dynamo scripts are mostly done with visual programming. Knowledge of any programming language on entry level isn't needed, and only more complicated scripts are made with visual nodes written in Python. So, like I said, we just encapsulate track axis with construction, and that's how we build our model. When we talk about construction model, level of detail and information, of course, depends on every project, on the way what we need to do. With TBM tunnels, modeling can be done almost fully automated, like I said. We encapsulate a railway model with construction around it. And with Dynamo scripts, is it possible to automatically divide tunnel into tube segments and model every layer of construction? But we don't design only TBM tunnels. We also design cut and cover tunnels. In both types of tunnels, we include every structural element like floors, beams, or walls. And everything practically depends on required LOD and LOI levels. LOD is level of detail and LOI is level of information. These models are then exported to create analytical models in structural analysis software, and with use of finite element method, we calculate the structure. But not only primary elements of structure are modeled, we also create elements like lean concrete or jet grouting injections. What is really helpful on further stages of design, and I'll talk more about it soon. When we talk about drawing documentation, like Kuba said before, just like in railway branch, 3D model is used to prepare all drawings. For over 70 years, our company focused on a very high standard of documentation. But there is very popular opinion that it is very, very hard or even impossible to reach level of detail of 2D sketches in Revit. But to be honest, it isn't true when we've got really, really good standards and templates. Of course, we start with plans, like we can see here. These plans, sections, and every other type of view needed are generated in model. And then with annotation Revit families and every other tool needed to recreate what was made in 2D before, we transform these views to create fully prepared project documentation that is ready to export and deliver straight to the investor. But like I said before, BIM isn't only about 3D model. It is probably the most important thing. It is the methodology and workflow of digitalization on every stage of the project. Even in model, or parameters are as important as geometry. We can check every measurement and property of any element in real time. On final stage of design process, we can use all these parameters and use it for automatically generated schedules. Then we use them in cost estimation process, and we reduce the amount of work needed in cost estimation. Model can also be linked with time schedule to create video visualization of realization process, and even on site to inspect execution time. And there are many, many other ways to use it, like, for example, model walkthrough in the video form, or even with use of virtual reality. Design process is just the beginning, and models are then used during operation and maintenance. Thank you very much.
Super, Kuba. I was waiting for this moment that you present the real usage of these tools, okay? Because we save a lot of time and a lot of money when you drop the automated process in, for example, the cost estimation of the line infrastructure, okay? Patryk, now is your turn, and we will focus at the signaling story, right?
Okay, hello everybody, I'm Patryk Bartuzi, I'm assistant CCS, CCS designer, and I'm going to tell you some interesting things, I hope so, about designing CCS systems in the BIM technology. So in general, creating a 3D BIM model for the CSS industry is based on placing 3D graphical representations of individual CSS devices, which are appropriately parameterized and are placed in specific locations. The 3D graphical representations of any CSS device is a family created in Revit software. My presentation is centered around the rail signal, which is the most elaborate and complex CSS device, actually. As you can see, Polish rail signals can vary from each other in terms of like the number of light chambers, light colors, position of the signal head relative to the mast, the presence and quantity of light stripes, quantity of individual indicators, and also the height of the signal head depends on the number of indicators and light stripes. So as you can see, rail signal can exist in multiple configurations, and modeling each one of them one by one could be very time consuming and labor intensive. So here is Revit. Revit software, in addition to creating just a solid that has a specific shape, also allows us assigning parameters to that solid, and by setting values of those parameters, we are able to control the shape of that solid. As a result, we obtain one family representing a rail signal, which can be repeatedly placed throughout the project space. For each individual instance of that signal family, we are able to assign specific parameters values to get to the required design scenario. So by setting values of those parameters, we can control, as you can see, the number of colors of lights and the position of the signal, the presence and quantity of light stripes, and of course, we've got indicators here. We can control the number and the specific type of each one of indicators. And please note that the family adjusts the height of light head depending on the number of indicators and lights types. So when we've got our families prepared like that, all that we have to do is to place them in a specific location according to the track axis and project space. To be able to determine that specific location for installing a signal, it is necessary to refer to track axis that contains the mileage data. The track axis, as you can heard before, track axis and all coordinate data are contained in the file created by railway industry using Civil 3D software. And here is one problem, because unfortunately Civil 3D and Revit software are not compatible enough to allow for loading the track axis and performing related operations within the Revit environment. So we had to find some solution, and we solved that by creating a 2D graphical representation of rail signals that can be used within the Civil 3D software environment. And that graphical representations of a rail signal in Civil 3D environment is a dynamic block. By placing those dynamic blocks along the track axis, we can get the mileage and coordinates, and we can use them in Revit environment. Something more about dynamic blocks. Dynamic blocks, they are actually equivalent of a Revit family. The dynamic block also has a set of parameters that are actually similar to those in signal family in Revit, and those parameters also allows us to determine values that can influence this graphic. But what is the most important? Dynamic block, after placing in the precise location, has a parameters related to that location that can be that can be transferred to signal family in Revit. So all of these data, such as mileage value, 3D project space coordinates, and also graphic representations, parameters of signal, by using the Dynamo script, can be transferred to Revit environment, and thereby generating a 3D model for the CSS industry. In summary, the workflow of creating a 3D BIM model for the CCS industry is as follows. Based on the track axis, as you can see on the picture, based on that track axis created by the railway industry, using Dynamo script, we can automatically put dynamic blocks of signal along the track axis and assign graphical parameters values to them. A script requires filling an Excel spreadsheet with information such as the mileage of a specific railway line and parameters values for individual signals. And running the script results in placing the dynamic blocks in specified configurations at the specified locations on the track. Based on the such prepared civil 3D file, using another Dynamo script, we are able to export all the desired parameters values, like graphical ones, and what is really important, coordinate parameters, to an Excel spreadsheet. From there, the Dynamo script imports necessary data to Revit environment, placing signal families in specific locations with specified parameters values, thereby creating a complete 3D BIM model for the CCS industry. We've got a lot of advantages of BIM in CCS system designing. I would like to say that with appropriate library of dynamic blocks and Revit families, it is possible to include every CCS device in the BIM model in automatical way. The proposed workflow ensures one space creating and updating the model would minimize the potential error in the project. It also guarantees full compatibility of 2D documentation with the 3D BIM model. We can also check the visibility of ray signal and another CCS devices. It gives us possibility to verify clashes with other infrastructure elements and cable roads. And there's also ability to generate detailed data reports also in automatical way. So at the end, as a summary of the whole process, our team has adopted in a practical method that involves step-by-step contributions from different experts. So now we can see a track input to the 3D BIM model. Then the construction designer incorporate the structure, considering the existing tracks. And finally, the CSS industry places their equipment, completing the project. And thank you for your attention.
Super. Patryk, can you please present the last slide of your presentation again?
Yes.
Okay,
Should
because
I click
this
it once again?
this is it. Okay, because this is the moment when all of you coordinate each other, right? So all of you guys, construction, let's say the track side, let's say the signaling system. So all of you three are coordinated here, right? We are a little bit out of time, but I would like to ask you some questions. And I was thinking about my questions, but to be honest, we have some questions from the audience. So let's focus on the questions starting right here. Okay. So first question is from Metodi, and it is addressed to the track site. Okay. So hello from Bulgaria, of course. Greetings to our colleagues from Bulgaria. And now, Kuba, I would like you to answer this question, okay?
Yes, so the question is, what is the distance between the center line of railway to the edge of the platform in Poland? So it's 1.675 meters. And the question that is connected with it, what clearance do you analyze and design? Do you have railway lines with other clearances? The main clearance which we analyze and which model we make is GPL2. And of course, a part of the main part of the clearance, we also make extensions in tunnels according to standards from, for example, PKP PLK or CPK. In any way we are expected to. So the answer is GPL2 is the main clearance that we use to analyze our models.
Thank you. Charlotte, maybe it is possible to catch somehow Metodi and let him, let's say,
I think I actually turned on his option to use the microphone.
Okay.
Let me see.
Maybe we can find Metodi just to let him say.
Yes, hello? You can speak if you want.
Metodi, yes. Are you there? Okay.
Yes, I'm here.
Okay, so hello to Bulgaria. The
Hello.
answer was okay from your perspective, or you want to add something or to extend the question?
It is okay because it is offset, platform offset according to the regulation by infrastructure subsystem. And the colleagues, they say that it is 1.675, right?
Right.
Yes, thank you.
So this is the railway talk. So if we are in Bulgaria, maybe you can just add few words about the high speeds in Bulgaria, how it is going in your country.
Yeah, it is going. We have a lot of projects in the main corridors between the border from the Serbia to Bulgaria and from the Serbia to the Turkish border. We are built high-speed railway for passengers and also for freight railways.
Okay, thanks a lot. And this is to Charlotte. It's of course your choice with Olaf, but maybe Bulgaria is the next topic in railway talks. Okay, second question. Second question is to construction. And this is a question raised by Pilayo, sorry, Escobar. But the question is from where? Can we check? Maybe you are still here and we can check. Charlotte?
Yes, Pelayo, if you can open your microphone, you can speak.
Yes, I was asking if it's possible to use the BIM technology on the maintenance phase of the project, like after the design phase, can the information be used on the maintenance phase or?
Yeah, of course. So
sorry, guys. We have to start from the beginning. Pilayo, where are you from? Sorry.
Sorry, I'm from Spain.
Okay, cool.
Yeah,
Jacob, your turn.
from Global Rail.
Okay.
Company.
Okay.
So hi, Pilayo. To be honest, the whole BIM methodology, it's the idea of the BIM methodology because in the highest stage of implementation of BIM, the idea is to deliver a model to investor that is practically full as-built documentation. So, for example, when we have all branches in model, like HVAC, or in our case, railway, for example. We have all specification of equipment, any, for example, material cards, or even with construction, we have every property of every element. So when we have any damage, any sort of problem, we model is a full repository of the knowledge about project. So we don't have to find anything. We just launch model, and we can find any property of any element of our building in it. So that's the idea of BIM, but we all know that it is very hard to achieve this level, and it doesn't work in this way already, but we all want to reach it.
Guys, I need to help you.
Maybe Wawrzyniec, can I say something?
Of course.
Because Pelayo is from railway branch, so I want to say that maintenance can be added as parameter to the parts of model maintenance periods. So you can start planning your time of maintenance or track closures just after you are finished with construction. So it's an example how you can use BIM model to in maintenance. You can plan track closures and everything connected to it. So it's money and work saving.
Guys, I need to add one thing. So we are a Metro project,
Okay,
right?
thank you.
And we have to highlight that we have some experience at the next level. Patrick, I'm looking at you because of the project of Warsaw subway line number 2, for example. We are at the totally different moment, right? There is the, let's say, level of line in operation, and there is a usage of BIM, right? So there is a minor, but still we have some experience in the next phase. Okay, next question is to signaling. The question is very short because it's CCS or CSS. The answer, Patrick?
Yes, those shortcuts we can use interchangeably, I think. But Wawrzyniec, you are a fresh signal designer, so maybe you have something to say about it.
I think that you answer on a chat, but the question was so short that I would like to give you the additional one. You have the question from, sorry for my spelling, but I cannot spell it, but Mr. Orlando from Romania. Okay, so greetings to Romania.
Okay.
And here is the question to you. Okay.
Yes.
Charlotte, sorry, maybe we can find the person who raised this question, because just to say hello.
Yes, Orlando is actually part of our presidium. So Orlando, you can enable your microphone, please.
How to pronounce the first name, because my name is
Orlando
also...
and the last name is Crăciun.
Crăciun, okay, because my name is also difficult. That's why we use Lorenzo. But okay, let's start.
Okay, so will you still use the classic lateral signaling? If yes, does it mean that the new line will also be used by trains with a speed of less than 250 kilometers per hour? As my knowledge at the moment is that at the current state of project there will be no signals between the stations. So yes, there will be the possibility to take a speed over 250 kilometers per hour.
Okay, so guys, you can see the questions from my side. So every one of you, each of you can pick the one, okay, from the list. Let's start from the track side. One of these three.
Okay, so I will choose the third question because, in my opinion, it's good question. How long does it take, and what is required to prepare for creating a railway model? So basically, all you need to have is software knowledge, and many software have all of the equipment in it that is needed to make basic model. The difficulties are when you have to, or when you want to create more and more complicated models. Then you have to create your libraries of styles, of cross sections, everything that is needed to make a complete model, and it takes a few months. But it's not as difficult as you may think, because there are many ways to help you in this journey to make the model. For example, you don't need to have a knowledge in programming. There are many ways to program visually, so everything at the start seems pretty impossible, but the more and more you're in it, then it takes easier, and you can see more and more possibilities to make the models more precise. So to answer it, you can start right away, but if you want to have a complete, very precise and very precise model, you have to spend some time, approximately a few months, creating needed libraries.
Okay, short questions, short answers. Okay, Jakub, pick one.
Maybe the first one. What are the main differences between models made with and without use of parametric design? So the truth is there isn't many differences between models, but the thing is that there is a huge difference between the way we create it. Because when we create model without parametric design, we have to define geometry of every structural or element from any other branch manually. So for example, when I create a slab, I have to define elevation of points of the slab. I have to do it just by hand. And when we use parametrization, we use the geometry of track axis. We define distance between axis and border of element, and they create automatically. So the thing is that on entry level, to implement this solution, we have to have some resources that that have the knowledge about programming that is needed, and it takes some time. But after implementing it, modeling is way easier and way less time consuming. So it is how it is.
Okay, last one to Patryk.
What is the level of detail in the execution of the presented families of railway signals, and how does it relate to real construction conditions? The presented signal families are kind of generalizations of the real model, and they were made according to the construction project. So they can't have such a detail that can show at some specific manufacturer or product or company. So they were modeled in kind of generalization, but of course the CAD software gives us a lot of possibilities. So if needed, we can model actually one by one as in real. Thank you.
Okay, Charlotte. So I think that we are close to the end because there is a 20 minutes past 6 p.m. in Warsaw. So
Yes.
this meeting was planned to 1 hour. I think that there is something that you want to add at the end. And of course, we would like again to say thank you, to Olaf, to all of the union. And we would like to tell you that this Railway Talks is just a 3rd edition. And I think that there is a huge plans for the 4th and 5th and 6th and 7th and so on. Okay. So thanks a lot again. Thank you.
Thank you very much to everybody watching. We have come to an end, and we are very much looking forward to applications from other countries. Please feel free to come up to us with your suggestions for the next Railway Talk, which will be in fall. We don't know exactly now when, but we're open to your suggestions. And with that, yes, I would like to thank Wawrzyniec for taking the role of moderator today, and to Piotr, Przemek, Patryk, and Jakub and Jakub. Thank you very much for your great presentations and for the very interesting content. And thank you for the audience for staying with us for such a long time and asking questions. So bye-bye. Have a nice evening.
Bye-bye.
Bye-bye.
See you. Bye.
Bye-bye.